petrol and diesel, which has been a part of our life for the last, part of our humanity rather, for the last 120 years. These fuels, which I will refer as fossil fuels, these fuels have proved to be unfriendly to environment. They emit a lot of carbon, which has led to global warming, which has a lot of other problems regarding sustainability of humanity on Earth. So there is a need to contain this carbon emission, which is increasing at an alarming level. So the world is looking for a solution. You and me cannot find a solution on this. Scientists and technologists have identified a solution using hydrogen. It's a new journey for humanity. We know the direction in which it is going to go, how much time it will take for us to reach the same comfort level which we are having with petrol and diesel today is not very clear. But there are some estimates, and I'll share with you as we go along. But I can tell you that many of us who are the audience today will see the beginning of some of this during our lifetime. Our children will definitely experience it, and they will see this transition from fossil fuel to hydrogen, because that is seen as the only solution to save the world or save the globe from the warming. I have structured this presentation for you in 3 parts. Why I did that was because it's a slightly complex topic. There is technology, there is economy, and then there is issues of how it can happen at a global level in all the countries. So I have broken down this presentation, which I'm going to make now, into 3 parts. And I want you to understand why I broke it down to 3 parts. The first part is, why hydrogen? Why not something else? Why hydrogen has been selected by the world technologists and scientists? The second part is, okay, you have selected hydrogen. How are you going to do it? That's the second part. And the third part is most important to us. How is this going to be done in India? So with this introduction, I will start my presentation. I would like to upload it. Sabu, can I upload my presentation?
Yes, sir. Yes, sir. Sure.
Okay, I'm sharing my screen. Okay, you're able to see it?
Yes, sir. It's coming. Yes, yes, sure.
Okay, so hydrogen is the next generation of fuel, and we are going to see it. Why have we selected hydrogen? Very briefly, but I'll go slowly because the topic is slightly complex. Right. We are familiar that for the last 100+ years, we have lived with LPG, petrol, diesel, kerosene, natural gas for various domestic as well as industrial applications. And we have machines which run on this. We have vehicles which run on this, equipment which operate on it. And today, if you take 72% of the energy required by the world today, I'm talking of today, is met by fossil fuel. And the balance 28% comes from solar, wind, very little wave energy, very little tidal energy. Hydroelectrics. When I say hydroelectrics, it is actually all those dams which have the electrical power generation, because that's also considered renewable, because when the rain comes, it gets renewed. And nuclear. In India, nuclear is considered as renewable. And world over also, it's considered renewable, except in a few countries. So 72-28 is the ratio today. And they all release CO2 to atmosphere. Can we find another fuel? This is the first part of the presentation. Look at this graph. Coal, oil, natural gas. The amount of energy they are giving to the world, it's huge as compared to hydro, nuclear, and other renewables. Of course, this study is based on 2021. It may be slightly worse now because a lot of industrialization has taken place. At the same time, some renewables also increased. So the global needs of energy is, I'm just sharing this number, 13,865 million tons you require every year. 13,865 million tons equivalent. Everything is with respect to oil, out of which some energy comes from coal, some energy comes from natural gas, but we are talking in terms of oil. India's rate is 900 million tons we want every year. India requires it. Some are produced in India, some are imported. And all countries in the world have got a mix of fossil and non-fossil. The most important aspect in this ratio is France. France has got 53% non-fossil and less than 47% fossil. But a large percentage of non-fossil comes from nuclear plant in France. So France is well ahead of all other countries, very closely followed by Brazil, which is 50-50. But USA, our friend USA, is 82% fossil and 18 is this. In India, it is 73 and 27, which we expect to become 50-50 by 2030. So please understand now, in another 7 years' time, our expectation is fossil energy will be same as non-fossil energy, mostly renewable, which will come to 50-50 in India. If you look at India's energy needs specifically, 43% is coming from coal today, followed by oil, followed by natural gas. And non-fossil fuel, I've given the list, which gives the balance 23% after deducting for coal, oil, natural gas. But remember, if you use coal, it produces a lot of carbon dioxide. And for the same amount of energy you get from coal, oil produces only 70% carbon dioxide, 30% less. And natural gas is even less, 50%. So coal is an enemy of carbonization of the globe. Just remember this. Coal is the enemy, primary enemy. And that is what India has got in large reserves. You've got lots of coal, but if you have to use it, you will be causing a lot of carbonization. So this factor you should remember, because as we go along, we'll develop the story. Now look at the carbonization or carbon dioxide emission. Total is what you see in the first graph. It's coming very close to 40 gigatons in a year. You see India is the lowermost here. China is there, USA is there. They're all much higher than us. India produced only 2.5 gigatons as of 2018. This graph is of 2018. But today it is estimated to be 2.8 gigatons. But there is a worrying factor in India. I don't know whether you can see the slide very clearly. India's growth is 5.1% in carbonization, which is far ahead of what is happening in the world. So we may be low in the amount of carbonization today, but we are growing very fast. And you can also say India's per capita carbon emission is very low because we've got a lot of population and it is much lower than the global average. That's also correct. But the fact is, we have contributed to global carbonization by about 2.5 gigatons, and it is growing at a high rate. Now, this carbon emission is coming from where? Who's producing this in India? Which sector is producing it? Let us see that. So we have forgotten about gold now, globe. We come to India specific. Let's see who's producing this in India. If you see in India, the consumption of energy and therefore the carbonization. I know that coal, oil, natural gas, they don't produce the same amount of carbonization. But I'm just saying, if you take the energy, if you take the consumption, the carbonization is almost related to that. Industry, 49% in India produces carbonization. Transports, cars, scooters, auto rickshaws, train, trucks, buses, they all put together produce 32%. Residential areas cost about 10%. This also takes into account the amount of electricity you consume. And to produce that electricity, somebody is burning coal. So that costs us 10%. Agriculture costs about 5% based on various equipment and others which you deploy. And the others are like this. So the most important thing, you look at only the first two. Industry produces almost half of the carbonization, and transport produces almost 1/4. Just remember these two, right? Now, in India, carbon emissions, coal-fired thermal plants. We've got large number of thermal plants and coal-fired ones, and there are some natural gas also. Both are there in India. They produce 1,100 and 100 billion tons respectively. Please remember, 1,000 billion tons make 1 gigaton. So India's total is 2,000, if you recall, 2,300, 2,400 billion tons, out of which coal is almost halfway through, coal, and then natural gas. Steel, cement, refineries, fertilizers produce about 800 million tons. The first one was for electricity generation. Coal-fired thermal plants and natural gas plants which produce electricity for us is the main component of our carbonization. Then comes steel, cement, refineries, and fertilizer. Transports come about, all the transports I talked about. So these three categories, that is thermal station, steel, cement, refineries, fertilizer, industries, and transports, they're called hard to abate. That means they don't yield. There is no solution, immediate solution. There is no easy solution to reduce their decarbonization. World agrees to that, and we have a big problem because 82% of our carbonization is coming from hard to abate. They are not easily solvable for us. We've got a big problem, even though our magnitude may not be as much as China or USA or Europe, but we have a big problem. So can we bring in a new fuel to reduce the level of emission? That's the question. The question is, of course, hydrogen, but can it reduce? Let's see how we go forward. So the new fuel which has to come has to have some qualities. So I will list about 5-6 qualities. It should be available in pure form. You all understand that. It should be efficient. It should have low CO2 emission. Why I said low CO2 emission? Even if you bring in a fuel, and that fuel is to be put in some container, compressed it, or just be driven through a pipeline, you still require some power. That power has to be generated. That power generation has got some carbonization. So it is not possible. There will be some associated carbon emission. You bring any fuel, you will have some associated carbon emission. It should be safe in storage because it'll be stored in many places in the cities, in villages, in rural areas. You should be able to distribute it all over the country. You bring in a new fuel, we should be able to, you should have a good distribution network. So, and you should be able to sell to customers. Somebody wants 2 liters, 3 liters, 10 liters of petrol, you're able to buy today. Tomorrow you bring another fuel, you should be able to buy it for your car or for your motorcycle. How are you going to do it? So the qualities required for the new fuel are this. And now let us see how hydrogen meets this. Hydrogen is available in the world in abundance, not independently as H2. I'll always refer as H2 because we are all familiar why in chemistry rather hydrogen is always existing as a molecule of 2 atoms, H2. But it's available as a compound called water. So you can always take it from water, hydrogen. And once you take it, it is light, colorless, odorless. You can have any purity. The energy density in hydrogen is more than 2 times what is there in diesel. So if you take hydrogen, you will get double the energy per kilo as compared to diesel or petrol. But 1 kilo of hydrogen will take a lot of space for you. It will have a huge container to have it because hydrogen is very light. So that's a problem. It may have energy, but it occupies volume. It has very little CO2 emission, as I told you, because then to reduce the volume, you compress it. For compressing it, you spend some energy, some CO2 is associated with that, and transportation, distribution, etc. But it is fairly less than what it is there in today's diesel and petrol. It can be compressed as a gas and transported in bulky vessels, or you can make it a liquid hydrogen. It's possible, but there's a problem. Liquid hydrogen requires minus 250 degrees centigrade minimum, which is called cryogenic temperature. And whichever container you keep the liquid hydrogen, it has to be insulated to make sure the temperature remains at minus 250 and above. When I say above, less than minus 250. It has to be maintained with the help of some other cooling equipment, etc. So there's a problem with hydrogen. So hydrogen is not coming there as a panacea for petrol and diesel. It comes with problems of storage, problems of transportation, problems of temperature requirement for storing it, and it is highly inflammable. So many places you don't transport hydrogen as hydrogen, especially to bulk consumers, to the industries. You make it ammonia. Many of you may remember ammonia is NH3, 1 nitrogen and 3 hydrogen. So they convert it to ammonia, and ammonia is transported, and the other end to split it again because it is safer. And for customers who want to buy hydrogen either as a liquid or as a compressed gas, mostly compressed gas for cars, buses, trucks, etc., then it is possible to have it delivered through petrol pumps. So hydrogen meets most of the requirement, but issues of inflammability, issues of being voluminous, and difficulties of it being safe. Even petrol is not all that safe. You have to follow procedures. Hydrogen requires far more adherence to this because hydrogen and oxygen can combine and catch fire. Okay. So hydrogen is the world has decided the next fuel is hydrogen, right? So scientists have added, it used to be used earlier as a rocket fuel because of high energy. I told you, it has got a lot of energy when it is allowed to react with oxygen. Energy is released. So it was used as a rocket fuel. And from there, now it is coming to commercial use. People have researched, you can have car, you can have train, you can ships, all running on hydrogen. How they run, I will explain to you as we go along. In power plant, it can be mixed along with natural gas and have more energy, and still it is safe. So they are finding methods by which hydrogen can be used in power plants also. All this is expected to bring down carbonization the next 10 to 15 years. So during our lifetime, we will see many of this happening, carbonization or carbon emissions coming down, primarily because of applications of hydrogen in industry, power generation, and transportation. So in the Indian context, if you look at it, it not only reduces carbonization, but it reduces our imports of oil. Now, all of you know that we import a lot of oil. Natural gas also we import a lot. But I don't know how many of you know we import coal. There's a reason for it. As you go along, you'll come to know. We got lots of coal, but we need to import coal. I'll tell you why as we go along. And therefore, hydrogen is required. It's called a feedstock that is required for industries to run the industry. So in petroleum refineries, we've got lots of refineries in India. Hydrogen is used for desulfurization. It is used. So you require hydrogen. Refinery requires hydrogen. How does it get hydrogen? Somebody either buy in bottles or it has to produce itself. How it will produce, how is it producing now? What are the problems? We'll see. But refineries require hydrogen. So tomorrow you have to continue refineries because petrol and diesel will not go away quickly. You still need to continue our refineries. You require hydrogen. Fertilizer, to produce urea, you require ammonia, and ammonia requires hydrogen. So petroleum refineries and fertilizers require hydrogen. I'll just show a very simple one. You see hydrogen is converted to ammonia, used for urea, hydrogen used for desulfurization, refinery, and you get petrol diesel. 100 kgs of hydrogen is required for 1 ton urea. We need to have your fertilizer for our agriculture. So you require lots of hydrogen. Today, it is being bought or being made by the fertilizer plant. How it is made, is it the efficient way? Is it causing carbonization? We will see. And similarly for refinery, 60 kgs are required for 1 ton of fuel. So large quantities of hydrogen are required for these two. And if you can minimize the carbon emission in production of hydrogen, as I told you, if you produce hydrogen, you will do carbon emission, then fertilizer plants and refineries can become more carbon efficient. Okay, so we have seen these two. Now, steel manufacture requires hydrogen because iron ore has to be converted to sponge iron. You must have learned this in school. So hydrogen is required. Power generation, where natural gas is being used, coal is also used, natural gas is also used. Hydrogen is mixed with natural gas to reduce carbonization. Just remember, power generation plant does not require hydrogen unless you are mixing with natural gas. Suppose you are burning coal, heating water, generating steam, and running a turbine, it doesn't require hydrogen. It may cause carbonization, but it doesn't require hydrogen as a feedstock. You don't have to buy hydrogen to run a power plant. But if you're running it on natural gas, then you can mix it with hydrogen and use the same equipment, same turbine you can use. So I'll just show that. Steel plant, as I told you, 50 kg is required for 1 ton of steel. And for power plant, 1 kg is required for 1 gigawatt of power at 5% mix. That means 95% natural gas, 5% hydrogen. If you do that mixing, then you require only 1 kg for 1 gigawatt of power. So here again, same, if you can find a better way of getting hydrogen, because hydrogen, somebody has to make hydrogen for you. If you can look at that process, then we can reduce carbon emission. So transportation, you require trucks, train, plane. How will they run on hydrogen? You require hydrogen compatible cars, vehicles, trucks, etc. If you're producing all this, it is not there except in some R&D or some prototype, etc. If they all have to come, then you can reduce carbonization by transportation. So I have finished with why hydrogen has been selected, and if hydrogen is selected, which all industries will have to find sources for hydrogen with less carbonization. So let's go forward. How do we produce this hydrogen for all these key sectors? That is a question. The major methods, now I'm looking at the question, how? How will you run industry? How will you run your car, bus, train? If you say no petrol, no diesel, only hydrogen, how will you do all this? That's what you're going to see in this second part. The major methods of hydrogen manufacture is, first, you burn coal with steam or oxygen or air, and you will get hydrogen as one of the components. You separate it out by a suitable method and you can get. But what is the result? You got hydrogen, but your carbon emission is very high because you're burning coal. Not a good idea, but that's one of the method. Second method, use heat up methane, that is natural gas, in a separate chamber. High heat, it splits into hydrogen and carbon. This carbon is not released to atmosphere, it can be trapped, and hydrogen can be there. But it is not energy efficient. You spend a lot of energy in electrical power to heat up, and the hydrogen production is not compatible, not commensurate to the money you spend. Third method, it's called methane reforming. Methane and steam are heated, mixed and heated. You will get hydrogen, but there is CO2. If you can capture the CO2, then this method is okay, because you're not allowing it to go to the atmosphere. So heat up methane and steam, generate CO2 and hydrogen, capture the CO2, and you get hydrogen for your industries. The fourth method is very simple, what you did in physics class in pre-degree, electrolysis. You split water into oxygen and hydrogen, no carbon emission. You get hydrogen separate, oxygen separate. And that hydrogen you put in bottles and send where you want, or liquidify it and send. So what is happening in India on these four methods, I will show you. The Indian status is coal gasification is happening in India, but they use only imported coal. Now I answer the question. India has got a lot of coal, but Indian coal is not used for this because Indian coal ash content is very high. It will produce more carbonization than imported coal. So if you have been reading about we are importing coal from Australia, we are importing coal from Indonesia, etc., primarily because Indian coal is not suitable for this application. That is on coal gasification. But 2 months back, in a place called Angul, Jindal Steel has made a plant which can gasify Indian coal. They have successfully done it, and they are also got the equipment to capture the carbon dioxide, but that second part of it is still not completed. But this is a new experiment. I'm sorry, not an experiment. It is a new setup which has happened in India. Methane pyrolysis, it is not there in India. Methane reforming, most common in India. Most of the industries in India produce hydrogen by methane and steam are combined and heated. That's what they do. But they release the carbon dioxide to atmosphere, and that causes carbonization. So hydrogen generation, which are required for industries, is causing carbonization also, and the industry also causes some carbonization. So this is not a very desirable one, but if you can somehow capture the carbon, then method number 3 is okay. So method number 1, not good. Method number 2 doesn't exist in India. Method number 3, okay, but capture the carbon. Method number 4 is new one. Not become, it is laboratories and some small level equipment is there, very low capacity. But if we can do this, then we can have hydrogen without carbon emission. So now I go to my next slide. I should warn you that there's going to be a lot of colors in this slide, but you'll have to remember 2-3 colors as we go along. So let me tell you, what are the types of hydrogen? Hydrogen is hydrogen only, H2. There is no type as far as chemistry is concerned, but it gets types, the name, based on how it was made, how efficiently it was made with respect to carbonization. That's how the name has come. So there are 5 types of hydrogen in India. First one, you use electrolysis, it'll be called green. If you can use electrolysis on renewable energy, it'll be called green. So just remember, green hydrogen means electrolysis on renewable energy. So you require electrolysis equipment, you require renewable energy, solar panel, etc., etc. you require. The second one is blue. Steam, methane, I told you, heat it up, but you capture the CO2, then it becomes blue. In India, it is not there. But I told you, Jindal has set up a plant in Angul, which is going to become perhaps the first plant which will produce blue in India. At the moment, blue is not there. Third is gray. Same thing, steam methane, but no carbon dioxide. This is in plenty in India. Release carbon dioxide to atmosphere. And fourth, if you are doing nuclear power, it is not popular in India. It has been tried out in some applications, but I know there's applications which are running in some of the naval platforms where electrolysis is done on nuclear power. So this is not meant for commercial applications at the moment. And the last one is coal gasification. This is called brown. So brown is not good. We already said that, even if it is foreign coal, not good. So brown is out, pink is not so rampant in applications. So we look at only green, blue, gray. Just remember this, green, blue, gray. Green is electrolysis on renewable energy. Blue and gray have same process, steam methane reforming. One is with capture of carbon dioxide, one is without carbon dioxide capture. Green, blue, gray. Right, let's go forward. So in India, if you look, I have shown various steel plants, various fertilizer companies on Indian map in different places. Now, in India, as I told you earlier, it's only brown and gray. There's no blue and green has not come yet. So 50 steel plants in India, 50. 23 refineries in India, 18 fertilizer plants in India, nearly 90 plus industrial plants are using brown and gray. And they are causing a lot of carbonization because they're not using blue, they're not using green. Green is not there anyway. There's no blue, no green. If you can bring blue and green, then your carbonization can be reduced in these 50 plus 23 plus 18 plants. So you have to go green, let us say. How to make green? Now, people have estimated that in 2024, we'll have only 0.15 million ton, but you require to really go up to 10 million tons by 2030 for giving all these plants, steel plants and fertilizer plants, all of them we need to be given hydrogen. So we need to produce a lot of hydrogen in green method. So how to produce green hydrogen? As I told you, it's electrolysis. There are 2 types of electrolysis. We'll not go into details, But there are two types of electrolysis. Function is split into hydrogen oxide. 1 million ton, if you want to get hydrogen, you require 18 gigawatts of power and 26 gigawatts of solar energy. I understand Matthew is there who's dealing with solar energy applications. For every million ton of green hydrogen for our industries, you require 26 gigawatts of solar energy. So if you want 10 million tons, you require 260 gigawatts of solar energy to be produced in India. Today, cost of green hydrogen is very high, $4 per kilo, while gray is 2.1. So people go for gray and don't bother about releasing carbon dioxide. But the government is coming with very strict orders. They have to use green, and the green money will come down as it becomes popular. Government is also giving a lot of incentives. I'll come to that a little later. Important aspect. If you want to produce green hydrogen, which is our requirement, the renewable energy should be nearby. That means you should have a solar farm. Next to that, you should have an electrolysis plant. And from there, hydrogen can be taken to whoever is the user. So imagine a steel plant having a solar farm, having an electrolysis unit, and taking hydrogen directly for steel, which is required for conversion from ore to sponge. Similarly for fertilizer, similarly for power plants. So make them integrated with the industry, with a solar pan farm and a electrolysis plant. Many plants may be required for the capacity that you want. And as I told you, storage of hydrogen requires high pressure cylinders, cryogenic cooling. And suppose you are not having place near your factory. There's water, no? Water has to come from somewhere. Good water has to come. So water also has to come. So you may find that all these are not very close to the factory. You want to transport the hydrogen to the factory. So you require trucks which will carry big cylinders, because hydrogen cylinders are very big because of their volume is high per kg. Or you'd lay a pipeline. So the entire hydrogen supply, hydrogen generation is capital intensive. Just remember that. You want to go to hydrogen, you require lots of money. You have to generate, you have to have a solar panel, you have to have electrolysis, you have to have pipeline, you have to have huge trucks, and then only it can reach the end user who is happily using coal today to burn it with steam and producing hydrogen, but inefficient and a lot of carbonization. So India, as I said, requires 10 million tons, most of it for domestic and some for export. But the government has allocated 20,000 crores in the budget, which was presented on 1st of February. On 1st February budget, if you have gone through the details, 20,000 crores have been allotted, some for R&D, some for pilot projects, and some for incentives for production, because people need to come forward. Industries have to come forward to produce the hydrogen, and you cannot sell it at $4 per kilo to a steel plant. The steel plant will not be able to afford it. So some incentives will be given to the hydrogen manufacturers for supplying to hard to abate sectors. Remember that. Steel, fertilizer, power plants, they're all hard to abate. You supply them, you will get some money from the government as incentive. So let's look at how hydrogen, now I finished with coal, steel, etc. Now I'm going to see how hydrogen will be there in future transportation. All two-wheelers, trucks transport, they're all running on fossil fuel today, you're aware of it. If you want to go to hydrogen, you have to make new vehicles, new two-wheelers, new trucks, new auto rickshaws. So I think a line has been drawn that you will not make two-wheelers and auto rickshaw on hydrogen. they will run only on battery. Electric auto rickshaws, e-rickshaw or e-scooter. But cars will become on hydrogen, and they will run on a new equipment. When I say new, relatively new for Indian customer, the car will have a fuel cell inside the car, to which hydrogen is fed from a bottle. It will take oxygen from air, combine it, produce electricity, and that electricity charges a battery. Thereafter, it's an electric car. So it is an electric car plus a fuel cell. Cost will be high compared to electric car. Cost will be much higher than compared to a petrol car. But petrol car is not going to be available after some years. So fuel cell driven cars you can have, fuel cell driven buses you can have, and some of the heavy vehicles. Now I'll show a vehicle. It will take from a petrol pump hydrogen. It will fill up, as I told you, it will fill in the tank, and from there it will go to the fuel cell as and when required. Now fuel cell drills, I should tell you, can run a small ship. Large number of fuel cells, hundreds of fuel cells put together in a huge place in the ship can run the ship. In fact, fuel cells necessarily have to be used in a submarine, because submarine cannot take oxygen from air. It is underwater. So fuel cells are kept, hydrogen is given in a bottle, and oxygen is also given in another bottle, and they are combined to run the submarine without diesel. This is already ongoing project in India, it's almost complete, just for information. Fuel cells can be used for trucks and ships and this. For heavy transports, heavy trucks, you can have IC engine, internal combustion engine, or I think there are many engineers here who know it very well, which is like a diesel driven truck. You put diesel and the engine starts, it burns diesel. Now you can have trucks like this. This was released in February 23 by Ashok Leyland, of course, for Reliance company. It has been run on an hydrogen IC engine. Similarly, in Europe, there is a ship which has been made running on hydrogen with IC engine, right? So IC engines have been made to accept hydrogen as a fuel, and it is burned in the cylinder, just like any other truck. It is already started coming to India. Ashok Leyland has been successful. There are many companies in the world which have been equally successful, and in fact, they have been successful last year itself. In Germany, hydrogen trains are being developed using fuel cells in August 22, some 5-6 months back. And Germany will soon have hydrogen run trains using fuel cell. In India's first train is expected this year in December in Kalka-Shimla route. The Ministry of Railways has already announced this, that in December 23, the first train will run in India using fuel cell. So I'm coming to the close of transportation. Two-wheelers, three-wheelers, leave them out of this. They'll be electric. Four-wheelers and above, they will run, if they're light duty, on fuel cell. If they're heavy duty, they'll have special IC engine which will run on diesel. Similarly for trains and ships. But all this requires hydrogen to be available in petrol pump. Today you're finding difficulty even to get a charging point sometimes for the electric car. But tomorrow you'll have to look for a petrol pump which has got petrol, diesel, because those cars will be running for some more years. And the hydrogen car will require hydrogen available on a petrol pump. So a network has to be created, storage has to be created. And of course, you have to find out methods by which how you will be able to sell to the customer 1 kilo of hydrogen. Now, I'm just showing some aspects regarding India's hydrogen in power sector. I finished transportation. I finished industry. This is the last part of it. That's power sector. Coal run industries is 50% in India. 58.4 power generation is from fossil fuel. Out of that fossil fuel, nearly 50% is coal. 6% is natural gas, and balance in some diesel and lignite, etc. But coal is a main player, and rightfully it has been given the black color. We cannot have this coal run plants run for future. We can use natural gas, and we can mix some hydrogen also with this, as I told you. And I want to tell you, NTPC ran the first set of turbines with 5% mix in January 23, 2 months back. So hydrogen mixed with natural gas is going to be used in the future for power generation. It'll give a higher energy and it'll reduce carbonization of 5%. Natural gas will be less, no? So less carbonization. So these are the future things. But government does not want to give priority for power sector at the moment. There are 2 reasons for it. Just remember, renewable energy is coming up in a big way in India. By 2030, we may have 500 gigawatts of renewable energy to meet the international commitment which India has given. So if 500 gigawatts is coming of renewable energy, a large percentage of coal-fired plants can be shut down. So don't waste hydrogen on power generation. And therefore, give priority for steel. We want steel. We want for transportation. That is, as I told you earlier, for vehicles, etc. And for fertilizer. Don't bother about power. So in the section on how we will live with hydrogen, government is planning no priority for power generation. Produce a lot of renewable energy, shut down coal plants, coal run plants. And instead, produce hydrogen, green hydrogen, electrolysis on renewable energy and supply for steel and transports and fertilizers. So now I'm coming to the third part of my presentation, last part. What is India going to do? Some of it I already covered earlier, but I will just do it at a macro level. First thing I want to tell you is there's a document which has been issued in Jan 23 by the government, by Ministry of New and Renewable Energy. It's on the net. It's a wonderful document. Those of you who are interested further can read it. Tell you what government is planning to do. Second, they have made a mission document with some few objectives, some 5-6 objectives. I'll quickly run through it. First thing, you have to align with COP26 commitment. COP26 is a commitment which I told you India has given the world meeting, which is called COP26, that we will reduce carbon emission by 1 billion ton by going into hydrogen. Is a commitment. And there, one more commitment was there on 500 gigawatts of power on renewable. So here I'm talking only on carbonization. We want to reduce our oil imports by enhancing renewable energy. We want to build capacity for 10 million tons, some for fertilizer, some for steel, and some for exports. We want to make green competitive so that gray hydrogen users will shift over. They'll shut down their gray hydrogen plant, which is using natural gas. Coal anyway has to be avoided, and then take green hydrogen instead. They want to blend green hydrogen up to 20% in natural gas for power generation. 5% has been already said successfully in NTPC Surat. So they are slowly going to 10, 15, 20. They want to make green hydrogen compulsory for heavy transports. I showed you a photograph of Ashok Leyland. So all big trucks, trailers, trucks, which are heavy duty, I think government is going to make it compulsory in another 10 years time, let us say. And they will of course set up network for distributing green hydrogen. popularize cars on green hydrogen fuel cell. I told you there are two ways. One is fuel cell, one is engine. So cars will run on fuel cells, which will produce electricity and then run like an electric car. And give a lot of incentives in the green hydrogen sector for export and tax policies, etc., which I mentioned briefly to you earlier. So if you look at this, government has, you see where all it is marked green. Government has identified many places in this area. It's a very interesting document. When you read it, they have selected these sites very close to industry. It has to be close to industry, otherwise the hydrogen has to go by road or by pipe. So bring the hydrogen plant, that is an electrolysis plant, close to industry, close to renewable energy. Correct? Renewable energy means solar or wind. Wind means offshore or onshore. So they have selected locations in such a way where solar energy is popular, including Kerala, there's one plant which is coming. And wind energy offshore will develop. And there are industries. So like that, they have selected locations. I'll come to the details a little later. And they've identified industry partners, Reliance, Adani, L&T, GAIL, NTPC, Indian Oil. They have all come forward saying they'll participate in this green hydrogen mission. While that is being worked out, they are busy, government is busy formulating regulations and standards, because you have to produce hydrogen, it has to be tested, it has to be certified, you require some standards, there are some rules regarding storage, safety aspects. All these rules, law, etc. are being simultaneously developed. So in 2023, government would have selected the locations, would have identified the industry partners, and formulated the regulations so that production of green hydrogen can come into full swing. So they have formed an alliance with industry partners to progress on all these fronts. It is called India Hydrogen Alliance. You see, the aim is to make 5 hubs, 3 on the west coast and 3 in the east coast. Now, these hubs will be where hydrogen will be stored, from where trucks will take away hydrogen. This will be the place from where hydrogen will be exported. So these hubs of, what are the hubs for? Electrolysis plant, renewable energy, and storage. All this will be very close to the port so that hydrogen can be easily exported. So they have identified 5 hubs, one in Andhra Pradesh, one in Tamil Nadu, one in Kerala, one in Maharashtra, and one in Gujarat. These are the 5 hubs. They set up 5 hubs. As I told you, by 2025, these 5 hubs will come and they will produce renewable energy as given in that slide. And one port will be selected for export. They're not selected so far, but will be very soon selected, where hydrogen will be stored in large quantity so that ships which come to take away the hydrogen, either they will take away the hydrogen in their own captive containers or tanks, or they will take huge cylinders from here and go. That is a question of details to be worked out. But there'll be one port which will be dedicated for export. Now, for doing all this, there are 10 ministries involved. This for information for you. First is New and Renewable Energy, who is a coordinator. Power plants are working. They have to blend hydrogen, so there's a power ministry. Refineries and power plants come under petroleum and natural gas, so there's another ministry. Fertilizer comes under chemical ministry. Steel comes under steel ministry. Hydrogen train will come under railways. Ports will come under Ministry of Ports. Of course, finance is required for export and tax policy. Road transport for heavy duty trucks, and external affairs for international cooperation. So these 10 ministries are working on a common program, the details of which is in the document which is on the net, which I told you. And this is one of the major programs I think India has launched where so much of interministerial cooperation and coordination is being attempted, and I hope this will become a success. So now I'm going to 2050. What will happen if this becomes success? By 2050, India plans to produce 28 million tons of hydrogen. I'm sorry, green hydrogen it should be. 28 billion tons of hydrogen, out of which 92 tons in green hydrogen. And it'll be used largely for export. Hydrogen will be used in India for industries, power generation, transport, and residences. Piped gas, natural gas will come to residences with hydrogen in it. It is being tried out. City gas distribution is at the moment is blending, and trials are started. And soon, in another 20 years' time, by early 40s, you will have piped gas. Your children, grandchildren may get piped gas with hydrogen mixed in it, so that they don't have to use LPG. Instead, they can use natural gas plus hydrogen. They'll export green hydrogen to Japan, Korea, EU. It'll obviously reduce imports of oil. There's no doubt about it. We're importing ammonia today because we can't make ammonia in India competitive. For ammonia, require hydrogen. All our hydrogen is made on gray hydrogen or brown hydrogen, which is causing so much of carbonization. So it's not worth it. So for coal gasification, we import coal. So government imports ammonia these days. So that will stop. Once you produce green hydrogen, you'll produce your own ammonia. And you will not import coal anymore for steel, because no more coal gasification. And imported coal is not required. Carbon emission is supposed to come down by 60%. Today, whatever emission is there, I told you beginning, 2.8 gigatons we are every year. 60% is expected to be cut by 2050. It's a very ambitious target. I hope we will reach somewhere very close to it. All this has to happen when steel industry is still working, fertilizer industry is still working, people are able to use cars, trains are running, trucks are running, power generation is still continuing. All this, of course, a lot of renewable energy comes in power generation, but all these industries and power plants have to continue running. Not only continue running, continue to meet future requirement also, which will be more than today's requirement, and produce decarbonization less. So it's a very, very, very orchestrated balancing of economical growth and decarbonization. Multiple sectors have to balance this out so that economy doesn't suffer because you're going to hydrogen. There's no interruption in production, and decarbonization targets are also achieved. This is a challenge for this program, which has been chalked out by the government till 2050. So in conclusion, I finished how government is going to tackle it. So let me come to conclusion. First thing is extensive use of hydrogen, as I told you, for hard to abate. The next 25 years will happen. Significant exports, hydrogen exports will happen, green hydrogen. Primarily, this is going to happen because India is going to be competitive. Lower labor rates and lots of solar and wind energy. So if you thought being in tropical weather, sweating it out in India has been a disadvantage as opposed to very lovely, comforting, cold climate of Europe. Now, please remember, sun is coming to save us. By form of solar energy, we will be able to produce green hydrogen. There'll be less carbonization, and we will be able to export green hydrogen in a big way. Other countries don't have so much of solar energy as much as us. other developed countries don't have so much of solar energy to meet their own requirement. So this is a great blessing for us, and similarly with wind. So hydrogen induction is going to happen. It'll reduce global warming, improve air quality, energy security, and it'll be sustainable, definitely. But hydrogen is not a silver bullet. It has to happen with so many other actions which has to be coordinated along with it. As I told you earlier, it has to be balanced with economic growth as well as decarbonization. It will help India in a big way in the geopolitical sphere and energy security. We'll be less dependent for oil. We'll be more on renewable energy, and we will be able to supply green hydrogen to other countries. So we will have our own provenance, and as such an economy, we're already fifth nation in the world. We will come to third or even higher by 2040s and after. We are planning to be energy independent by 2047, 100th year of independence, when we will not import oil from abroad. We will have our own. We got a little bit of oil in India and mostly renewable energy. That's the aim of the government, and to become a global hub for green hydrogen. And as I told you, all this will happen when you balance it out very well. So green hydrogen is efficient, affordable, because lots of production, so cost comes down, and sustainable because it's available in plenty in the globe, in the world, in the form of water. So, ladies and gentlemen, I have concluded my presentation. If there are any questions, I will be very happy to answer them. I hope I've been able to take you through this hydrogen story, which is going to happen in India in the next 25 years or 25 years plus. Why we selected hydrogen, how this will happen, and what is India's specific plan, and how we will have a very coordinated implementation program. Jai Hind. Thank you.